going in that direction. I just subtracted to find the difference between the two of them. And it's going in the direction of the larger one. Does that make sense or not really?
A little bit.
A little bit? Okay. So the equal amounts of force just cancel each other out. And then the one that has leftover, the whole thing's going to kind of get pushed backwards. So if they collide, but this one's stronger, then it pushes both of them that way. If they collide and they're both the same, they just stop there. If they collide and this one's stronger, it pushes everything back that way.
Taylor, what happened to your eraser?
So, that is basically the east and west ones. You're just going to find that and subtract. The other ones, you're going to have to find the horizontal component. And that's what we were talking about the other day.
So the horizontal momentum of my ball.
Yeah, exactly.
Jimmy Waters.
Let's take another option.
Baby.
I was thinking with the JW, Jimmy Waters.
No, Jimmy is surprisingly inappropriate often.
Is
Yep.
I thought
that his really?
Yep.
Wow.
He wrote that?
Yeah.
Oh.
Which one?
Saw the horizontal momentum of my balls.
I saw that. I was like, what the crap, Osmond? Oh, GW.
No, you would think it would have been Osmond, wouldn't you?
Yeah.
I just gave him a you must be 8 look and just ignored it, but he didn't find it discouraging enough.
Cena was rapping like that kind of. He was like, because he was dissing The Rock, and he was like, Rock, you're like a guy in a bowling alley who polishes my balls. And then he was like, you're like a purple pinwheel, so go ahead and blow me.
I think you're guilty of that, Jamie.
What the crap?
Where'd the purple come from?
Oh, his color is purple. Rock said it was a big bowl of 3 pebbles.
Jamie, maybe you should put more.
That's funny. The
Wait,
baby
you mean The
pebbles
Rock
are
is in
so
Dwayne
good.
The Rock Johnson? He hasn't wrestled in years.
He came back.
Oh, nice.
He's hosting
needs money.
WrestleMania.
He only came
I
back.
thought he was
when
an
needs money.
actor.
I thought he made
He
hit
is.
movies.
He doesn't need money.
That's the Rock part. He's
Why
doing
else
The
would you
Rock
go back to
Johnson.
wrestling? Come on now.
He's not
Okay,
wrestling.
so-
He's being an announcer guy.
No,
Ladies,
he's the host of WrestleMania.
you know what, Jamie? It's okay. We're focused on this. So, let's say you have 2 things, and they have different momentums. Let's say one has a momentum of like 30, and the other one has a momentum of 80. Okay? So we got that part by just multiplying the weight times the speed.
Are you doing the balls one?
No. You're going to get me now.
Oh, great.
I'm just
Yay.
making I know, isn't that awesome? So this one is like, we'll have 2 things. This is 3 pounds and 10 miles per hour. And this is 8 pounds, also 10 miles per hour. Does that make sense, Taylor?
Yes.
Okay. So I'm just making up some numbers that were easy to deal with. You could pick things like 3.8, but I don't think there's any need for that.
That would be really bad.
Yeah, I mean, real stuff, unfortunately, sometimes doesn't weigh even amounts, but in made-up problems, you can just make nice numbers.
Yay, I like it.
Now, we're going to say that this one goes at 20 degrees, and this one goes at, I don't know, 45. Okay? So you've measured that from the middle.
I have a question. If it's 3 pounds and 8 pounds, then why is it 30 and 80?
Oh, because to get the momentum, you multiply this times its speed.
This is not here to
And
do
in this
our
one,
butt
I
dance.
just made them both have the same
butts.
speed to make our life simpler.
Got it. And so then the
I
momentum
won't
becomes
practice something
the
today.
Exactly. That's
Oh.
the hypotenuse.
Makes
Now, if you imagine, Taylor, this thing could have more momentum than the 8-pound one if it was going super fast. Like if it was going 100 miles an hour, it'd have 300 pound miles an hour of momentum. Whereas this guy would only have 80. So a really light thing that's going fast could have more momentum than like an elephant that was going slow. Okay, so then we've just got to find out this for each one. This is called the horizontal component, and that's how much, sort of like what percent of the momentum is actually directed towards each other, and what amount is just them skidding up and down and not hurting anything. To do that, you could use sine or cosine or tangent, whatever you prefer.
Sign.
I like sine best too, so we'll use that. so we'll just call this X, and we'll call this one T for Taylor. All right, and so I would do sine 20 equals X over 30. For this guy, I would do sine 45 equals T over 80.
On our quiz tomorrow, didn't you have to
We have a quiz tomorrow?
Yeah.
It's
They
gonna
have to
be
be
just like
Say
this.
what?
There's gonna be like 2 problems like that.
Do they have to be to scale like our
Yeah.
Good, because
If you choose to do it by measuring, it needs to be to scale. But if you choose to do it by sine and cosine, it doesn't have to be to scale.
woohoo!
Well, I need to write down that I have a quiz.
I don't really, like, I kind of, like, get, like, and get it, but I can't, like, do it, if that makes any sense.
Yeah, it does make sense. So let's finish this one up first, okay? So, yes, Taylor.
The angles, where'd they come from?
The angles, oh, you had to be given them the problem.
Oh,
They were like, it hits at a something degree angle.
Oh.
So this one hit at a 20 degree angle.
so the one for the 30 momentum is a 20.
Yes,
Okay.
it's blobby, but that's what it's supposed to be.
Okay.
Now, to find out how much the X and T have towards each other, we just multiply.